Hello everyone, Mr. Hissner here, and today we're going to be looking at what are called shaded regions. And this is basically, we have two figures that have, that we can find the area of, and then I need to actually make this white. And then we take the one and subtract it from the other. The last time we looked at these, we took the one area and the other area, we added them together. Now we're going to be subtracting the one from the other. So let's take a look at what that looks like over here. So what I'm going to do is I'm going to just jump right into this figure. So this idea is we want to find the shaded region, right? So we want to find this shaded region. However, there are two figures here still. Right, we have this rectangle, and we have this triangle. So what we're going to do is we're going to find the area of the rectangle, and then we're going to remove the triangle, and what we will be left with is the shaded region. So let's find the area of the rectangle, and we need to find the area of the triangle. Well, this is length times width. This is base times height divided by 2. So the length times the width of the rectangle, this one's easy. This is simply 14 times 25. 14 times 25 is 350. And then the base times the height. Well, we know that both sides of a rectangle are the same, right? So if that one's 25, then this one has to be 25. So we know that the base of this is going to be 25. And the height, well, this is the height, right? Here is what I was just going on about in that last video. Here is our right angle, our dotted line. This is the insignia. This is letting you know that this measurement is the height of the unit. So 25 times 11 divided by 2. I'm going to show you how I do this in the calculator quickly. So this is 25 times 11. This is the numerator. So I'm going to find what that is. Then I'm going to use the denominator. Well, it was 275 divided by 2. 137.5. Okay, so this was the whole thing minus the piece we want to remove, and this is 212.5. These are centimeters squared. The idea here is, well, this one, we have to be removing the bigger piece, the smaller piece from the bigger piece, right? If you can just imagine taking this red piece and just removing it from the rectangle, then you'll find what's left over, which is just our shaded region. Let's look at another one of these. So here we go. We have some stuff. We're given a weird thing here. We're given this piece is 9, and we're given that this piece is 21.6. But there should be a right angle in here because if this is a right triangle, which it needs to be, then we can find the hypotenuse by using the Pythagorean theorem. This is actually a very common theme in these. So 9 squared is 81, 21.6 squared is something, and then when you add them together, we get 546.56. And that's c squared, and then of course we need to square root both sides here. We want 2 decimal places when we do stuff like this. So we find that c, let me put this in a c is equal to 23.4. And that is this whole piece, right? This is the diameter. But what we would need here still would to find the area of so we have the area of a semicircle and the area of a triangle. Semicircle would be pi r squared. That's the area of a circle. So the half the circle is going to be divided by 2. And again, this is going to be base times height. We know that's divided by 2. So what is the radius of the circle? Well, the radius is going to be half of the diameter. Well, what's half of 23.4? It's 11.7. And so this looks like pi times 11.7 squared divided by 2. I'm going to get this value. And then the base times the height of this triangle. So notice, if I were going to redraw this triangle, be careful because this is 23.4, this is 21.6, this is 9. And remember that the base of the triangle and the height are perpendicular. So the base is 9 and the height is 21.6. And then this is going to be divided by 2. So let's do the top and then we'll do the bottom. So this is pi times 11.7 squared. Pi times 11.7 times 11.7 because that's what squared is. It's when you multiply something by itself. And then this looks like it's just going to be 430.05. Oh wait, it's a half a circle. It's a semicircle. So divide by 2. 215.0, right? That's just a flat 215. This looks like it's coming out to 215.03. I'm taking hundredths. That's what we were told. Okay, and then we need to do 9.9 times 21.6 divided by 2. 9 times. You can't just type it in. You want to hit enter. 9 times 21.6. Enter. Take half of that. Divide by 2. Enter. 97.2. Did I get that one right? Yeah, and now we want to add these two things. So no, we want to subtract. We want to subtract the small one from the big one. This is the shaded regions. Really, that's all we're doing here, right? Big number, small number. Just take the big one from the small one. If you do the reverse, you'll get a negative number, and you can't have a negative area. You can't owe someone area. That doesn't make sense. 117.83, and these are meters squared. And that's where we're done. All right, guys, this is how we do it. The idea here is we're looking for the shaded regions. We want to take the big shaded from the small shaded from the big shaded. It's like composite figures, except at the end, instead of adding them together, you just subtract the small one from the big one, and you get your answer. Thanks for watching.